Simplifying rational expressions. In this video, we'll simplify rational expressions with polynomials in the numerator and the denominator. We'll learn techniques to avoid common errors, and we'll simplify expressions with opposite factors. To simplify a fraction like 20 over 25, we factor the numerator and denominator and cancel factors that are the same. This gives us an equivalent fraction that's simpler, which means that 20/25 takes up the same amount of space of 1 whole as 4/5 does. To simplify a rational expression, we factor and cancel. But even though you know this, and you would never, ever write that 8 over 2 is equal to 5 plus 3 and 5 minus 3 and cancel the 3's, you would never do that, but somehow an expression like this one represents unbearable temptation. And students want to cancel the x squared and divide 5 into 15 and 2 into 6. This is just not correct. No. To simplify a rational expression, factor, then cancel. If I factor the numerator, x squared plus 2x minus 15 factors 2. Well, negative 15 is from 3 times 5, and if I add 5 and subtract 3, I get the positive 2 in the middle. There's the numerator. How about the denominator? X squared plus 6x plus 5 factors x times x, and the only factors of 5 are 5 and 1. If I write x plus 5 times x plus 1, I get that 6 in the middle. And I can cancel. I can cancel the whole expression x plus 5 with the exact same expression x plus 5. And that just leaves me with x minus 3 over x plus 1. That's the simplification. Now I can imagine you saying, wait a minute, you said I couldn't cancel the things that were added before, but x plus 5 is added. Why can you cancel that? And the answer is that the factor is the whole piece altogether. It's x plus 5. There's 2 terms in the factor. The factor is the binomial. And when we cancel binomial factors, they have to match exactly. Whenever you find yourself thinking, can I cancel anything here? If you don't know if something is mathematically legit, try replacing the variable with a number. For example, if you want to cancel x plus 5 and x minus 5, try it with a number. Pick any random number. Let's pick 10. 10 plus 5 is 15. 10 minus 5 is 5. Can I cancel 10 plus 5 times 10 minus 5? Do I get the same thing on the top and bottom? No, I don't. Binomials have to match exactly to be canceled, and if you're not sure, try replacing the variable with a number. X minus 3 over 3 minus x. Can I cancel anything? Well, it sure doesn't look like they match exactly, but let's try writing them in the same order. It's nice to have the variable first. When you're rewriting them, be really careful with signs. The x is negative and the 3 is positive. Whenever your leading coefficient is negative, the coefficient of the x term with the highest power, try factoring out a -1. So I'm going to factor out -1 from negative x plus 3. That means I'm dividing each one by a negative, which changes the sign. So -1 times positive x gives me back negative x, and -1 times -3 gives me back positive 3. So it surprisingly turns out that even though they didn't look the same when I started, I have a common factor of x minus 3. Now, whenever you cancel, you leave a 1 behind. You're really writing x minus 3 over x minus 3 as 1. So this is 1 divided by -1, and it's equal to -1. If you take the original expression and try it with a number, any random number, we're going to try it with 10. I have 10 minus 3 on the top is 7, and 3 minus 10 on the bottom, it's -7. It does simplify to -1. And in general, any number you try except for 3, because 3 gives us a 0 in the denominator, but any other number that we substitute for x will turn out to simplify to -1. These are called opposite factors, and they're a really tricky part of factoring. So here's my hints for simplifying rational expressions. First, if terms are in the different order in the numerator and denominator, rewrite them so that they're in descending order of powers. And factor a -1 if the leading coefficient is negative. I want to simplify x squared minus 81 over 9 minus x. First, x squared minus 81 is a difference of squares. It's x plus 9 times x minus 9. The denominator, 9 minus x, isn't written in the right order. We should write the x term first. It's a negative x, and the 9 second. It's a positive 9. Since the leading coefficient of the bottom is negative, I'm going to factor out a -1. And I'll get x minus 9. Now I can cancel the two factors x minus 9. X minus 9 cancels with x minus 9, and I'm left with x plus 9 over -1. Now, over -1 means divide each one by -1, so that gives me -x minus 9. That's the simplification.